All right, thanks for watching. And today I would like to do a couple of problems using the double angle and the half angle formula for sine and cosine. So let's start with an example. Suppose in this case that cosine of an angle theta, so suppose cosine of theta equals 3/4. And also that angle is, I believe, in the fourth quadrant. So with theta is between 3π/2, theta and 2π. And the question is, first of all, how would you calculate cosine of 2 theta? Okay. Which leads me to the double angle formula. So first of all, it is not, be careful, it's not the same as 2 cosine of theta. Okay, so there is no law where you can just pull the 2 out. Instead, what you have to do is to use the double angle formula for cosine. And here's how I remember this. So remember cosine squared plus sine squared equals 1. Well, there better be a law for cosine squared minus sine squared. And indeed there is, which is the following, namely cosine of 2 theta, that's cosine squared, minus sine squared. So this is the first important formula you have to remember. All right, so that's first of all, the only issue is, well, here we only have cosine. We don't have sine at all. No problem. There are two ways. Either you figure out sine from this equation, or it turns out there's a way to clean up this formula. Because notice, again, cosine of 2 theta, that is cosine squared minus sine squared. But now sine squared, that's nothing else than 1 minus cosine squared. Again, by this formula. Square root of theta, which if you want, then simplifies to a cosine squared of theta minus 1 plus cosine squared of theta, which then becomes 2 cosine squared of theta minus 1. And this I wouldn't even memorize. I would just memorize this formula and then just prove this. But great, so how does that solve a problem? Well, remember cosine of theta was 3/4, so you just plug this in. So again, cosine of theta was 3/4, and then from this we get cosine of 2 theta equals 2 cosine squared of theta, so 2 times 3/4 squared minus 1, and you simplify that, so this becomes 2 times 9/16 minus 1. So this 2 and this 16 cancel out, or simplify to get 9/8 minus 1. And that becomes 9 minus 8/8. And that's 1/8. So it turns out in this case, cosine of 2 theta is 1/8. Now, of course, the next question is, what is sine of 2 theta? And for this, we need another formula, which is simply as follows. So it turns out sine of 2 theta is just 2 times sine of theta. Okay, so like pulling the 2 out, but then remember you have to multiply this by cosine of theta. So that's the second formula. And again, the way I remember this is just think of expanding, let's say cosine of theta and sine of theta squared. Well, that becomes cosine squared plus 2 cosine sine. So plus 2 times cosine times sine plus sine squared. Well, this middle term is precisely sine of 2 theta. But again, it's just a mnemonic device. The question is, how do we solve our problem now? Well, remember, cosine of theta was, what's called? Cosine of theta was 3/4. So we already found cosine, and so the only question remains is what is sine? And in order to do that, remember, you have to use the important identity that cosine squared of theta plus sine squared of theta equals 1. So sine squared of theta equals 1 minus cosine squared of theta. That becomes 1 minus 3/4 squared, and that's 1 minus 9/16, and that simplifies to 16 minus 9/16, and I believe this becomes, so 7/16. Okay, let me double check. All right, so we have that, and then, sorry, I was confusing it with something else. And so what we get now is sine squared of theta equals 7/16, which means that sine of theta, well, it's plus or minus square root of that, okay, which becomes a plus or minus square root of 7/4. Now the question is, of course, is it plus or is it minus? Well, from this, you have to remember the stuff at the very beginning. Namely, theta is between 3π/2 and 2π. In other words, theta is in the 4th quadrant. It's somewhere over here. And remember, we wanted to find sine. Well, sine is just the y-coordinate. And in particular, the y-coordinate here is negative. So sine of theta has to be negative, whereas cosine is positive here. So if it's between plus or minus, the answer here is minus. All right, so let's go back to our problem. So it's not plus square root of 7/4, it's minus square root of 7/4. And then last but not least, we now have all the ingredients we needed. Sine of 2 theta is 2 sine of theta cosine theta, and that becomes 2 times minus square root of 7/4 times, I believe, 3/4. That's what we had. And this then simplifies, so this 2 cancels out with this 4 to become 2, and we get minus 3 square root of 7/8. All right, and last but not least, I'm not going to do this in detail, but what if we ask you to do tangent of 2 theta? Then you would just use sine of 2 theta over cosine of 2 theta. So you would just put the ratio of the 2 answers you found. All right, very good. So that was the double angle formula. It turns out there's another formula called the half angle formula. So let's do another question with this. And by the way, I mean, as an interlude, if you want, the same thing goes in reverse. So sometimes we could ask you to find something like this. So simplify, or maybe even better, simplify 16 sine squared of theta cosine squared of theta. Well, that becomes 16 sine of theta cosine of theta squared, again by definition. And because you see sine times cosine, that should remind you of the double angle formula. Sine of 2 theta is 2 sine of theta cosine of theta. So if you divide this by 2, you get sine of theta cosine of theta. equals sine of 2 theta over 2. Which means you can just plug this back into this equation. So this becomes 16. So you see this expression is the same as this expression. And you're left with sine of 2 theta over 2 squared, which simplifies to 16 sine squared theta over 4, and that becomes 4. It's a sine, very important, sine squared of 2 theta, my bad. Two theta over 4, and that's 4 sine squared of 2 theta. Just beware that you might have to do it in reverse. All right, so now going back to the main topic du jour, which is, double angle and half angle formulas. So now let's do the opposite example. So suppose cosine of theta is minus 5 over 12, and that's in the third quadrant. Okay. So pi, theta is between pi and 3 pi over 2. And the first question is, how would you find cosine of theta over 2? And again, there's no, technically shouldn't need to memorize this, because this actually follows from the double angle formula. So let's start here again. Cosine of 2 theta. What is this? That is, or maybe to make it even easier, let's do cosine of 2x. You'll see why. So cosine of 2x equals cosine squared of x minus sine squared of x. And let's write this sine in terms of cosine. You will see why. Because this then becomes cosine squared of x minus 1 minus cosine squared of x. And that becomes cosine squared of x minus 1 plus cosine squared of x. And that becomes 2 cosine squared of x minus 1. Or in other words, what happens here, and again, you will see why I'm doing this. 2 cosine squared of x minus 1 equals cosine of 2x. So 2 cosine squared of x equals cosine of 2x plus 1. And lastly, cosine squared of x equals cosine of 2x plus 1 over 2. And so what this tells you is that cosine of x is plus or minus square root of that. So cosine of 2x plus 1 over 2. Now, why is this useful? Because this thing expresses a smaller angle in terms of a bigger angle. So if you want to calculate cosine of theta over 2, okay, you would just let x be theta over 2. You see, this is valid for all x. So it's also valid for theta over 2. And what this becomes is simply plus or minus square root of cosine of 2 times theta over 2. Right, plus 1 over 2. Now the 2's cancel out, and at the end you do get the half angle formula. Cosine of theta over 2 equals plus or minus square root of cosine theta plus 1 over 2. And again, do not memorize this, because again, you can just derive this. So let me repeat the steps. I know it's a bit long, but you start with the double angle formula. So cosine 2x is cosine squared minus sine squared. You use the fact that sine squared is 1 minus cosine squared to get an expression purely in terms of cosine. Then you solve for cosine. And literally what this is saying is cosine of a small angle is plus or minus cosine of a bigger angle, you know. So in this problem, what we get is, again, we had to calculate cosine of theta over 2. So in this case, this becomes plus or minus square root. So cosine theta was minus 5 over 12 plus 1 over 2. I know it's quite nasty, but you simplify this. So square root of minus 5 plus 12 over 12 over 2. And this becomes plus or minus square root. So this numerator becomes 7. And remember here, you have to multiply the denominators. It's like dividing by 2 over 1. So multiplying by 1/2. So we get cosine of theta over 2 equals plus or minus square root of 7 over 24. Which again raises a question. Is it plus or is it minus? And for this, you have to look again at the quadrant. So where was it? Yeah. Right, so what do we have? We have that theta is between pi and 3 pi over 2. So theta is in the, theta itself is in the third quadrant, but careful, we don't want theta, we want theta over 2. So theta over 2 is between pi over 2 and 3 pi over 4. So you just have to be a little bit careful. So pi over 2 is 90 degrees. 3 pi over 4, I believe, is 135 degrees. So pi over 2 is actually in this region. And what is cosine here? Well, cosine turns out is negative because we are in this region. So the answer is minus. So again, just as before, the answer is minus, but careful, sometimes it could be plus, depending on where theta over 2 is. Cosine of theta over 2 equals minus square root of 7 over 24. All right, good. And then, of course, the next question is, what is sine of theta over 2? Well, it turns out there's a similar formula which I believe is just the same thing, but with minus. Let me just double check. Let me check. Yeah, so before we had 1 plus cosine of theta over 2, but now it's plus or minus square root of 1 minus cosine of theta over 2. And again, you just do it similarly, but you solve for sine. But I don't want to waste too much of your time. Ooh, that rhymes. And you get plus or minus square root. In this case, cosine was again minus 5 over 12. So 1 minus 5 over 12 divided by 2. And this becomes plus or minus square root of, so 1 plus 5 over 12 divided by 2. Which then just simplifies to plus or minus square root of, so 12 plus 5 over 12 over 2. And I think now you just get plus or minus 17 over 24. Kind of weird numbers, but again, the question is this plus or is this minus? Well, just go back to your trig circle. I believe it's over here. Well, remember, theta over 2 was in this region, and in particular, sine is positive. So in particular, it's this case, it's plus. So plus, and therefore answer is plus square root of 17 over 24. And of course, I will not do this, but if you want to know tangent, you just use sine over cosine. There's probably a formula for this, but like I went to a French school, and like they say in France, pourquoi faire simple si on peut faire compliqué? Why make things easy if you could then make them complicated? And perfect with this. Thank you for watching. And if you like this and want to see more math, please make sure to subscribe to my channel. Thank you very much.